Okay, so for this established identity problem, in the notes, I actually started working with the right-hand side. And instead, I'm going to start working with the left-hand side once again to show you that there's more than one way of doing this. So in the notes, I did common denominators, fractions, use identities, and everything like that. This time, what I'll do is I'll start with the left-hand side, so I'm going to put in the formulas directly from our list of sum and difference formulas there. So for cosine, I'm going to do cosine x, cosine y, and then we're going to do minus sine x, sine y. That's the identity for the formula for the first one. The bottom one, I have cosine x minus y. I'm going to use this one. Cosine x, cosine y, then plus sine x, sine y. So now I have the correct identities in for both of those. Now this side I'm not going to do anything with. I'm going to leave this one alone. Okay, so now I want to make this left-hand side look like the right-hand side. Now if you are going to go about it this way and you started with the left-hand side, this is a little bit harder than the one I showed in the notes because this step here you may not recognize what to do next. We kind of reach a roadblock. So then you start looking at what do I have to get on the right-hand side and how can I make the left-hand side look like that. What I notice, the most important thing I notice here is there's a 1 in front of each of these. So because there's a 1, that means that I need to somehow make that first term into a 1. I already have the correct signs. I have a minus plus, and that's minus plus there, so that's done. If I could somehow make that into a 1, that's what I want to do. Now the only way to make that into a 1 is if I take this and I divide it by itself. Now I'm not talking about cross-canceling, I'm not talking about that. What I'm talking about doing is taking cosine x itself and cosine y and dividing that by itself, cosine x, cosine y. That's what I want to do. If I can do this, then that's going to create the 1 that's going to be over there. Now I can't just go ahead and put that in and leave everything else the same. What I do to the one down below, I have to do to everything else. So basically what I'm doing is every single thing, top and bottom, I'm dividing them all by cosine x, cosine y. So I'm doing that down below here, cosine x, cosine y over itself. And then this one, I'm doing the same thing as well. Sine x, sine y over cosine x, cosine y. So technically, what I actually did here was I took the top and bottom one, and each one I actually multiplied by 1 over cosine x, cosine y. So I did 1 over cosine x, cosine y on top. I did 1 over cosine x, cosine y on the bottom. So I'm really multiplying by a power of 1. So essentially what we're doing is every single thing top and bottom, as long as you divide everything by the same thing at top and bottom, then that's an okay process to do. Okay, so this side, the right-hand side, I still have not done anything with. So I'm just going to go ahead and carry that down as before. So I'm just bringing that down. Okay, so now that I have this, I need to do some simplifying. This over this, that's 1. That's what we originally wanted to have it turn into. That's why we did that process in the first place. Now let's take a look at this. You have sine x over cosine x, which is going to be tangent x. That's our definition for that. Sine y over cosine y, that's tangent y. On the bottom, I have 1 plus tangent x, tangent y. So everything here on the left-hand side, that all actually equals what I have on the right-hand side. We just go ahead, we brought that down all the way, and we've shown that the left-hand side can be taken all the way down to equal the right-hand side. So I worked this out all the way through. I did a little bit different way than the notes because I start with the left-hand side, but just showing you that sometimes you're allowed to start with either side and you can get the answer either way. What we get as a result was different than the notes because in the notes I showed both sides were equal to this one, but it doesn't matter. As long as you show both sides are equal and you can show logically how you reach that point, that's really all that matters.